Hello, everyone, and thank you for joining us for today's webinar, Discover New Machine Learning Use Cases for Hadoop with RapidMiner SparkRM. I'm Haley Mattisau with RapidMiner, and I'll be your moderator for today's session. We're joined today by Jesus Puente, our product manager here at RapidMiner. Jesus will get started in just a few minutes, but first, a few housekeeping items for those on the line. Today's webinar is being recorded, and you'll receive a link to the on-demand version via email within 1 to 2 business days. You're free to share that link with colleagues who are not able to attend today's live session. Second, if you have any trouble with audio or video today, your best bet is to try logging out and logging back in, which should resolve the issue in most cases. Finally, we'll have a question and answer session at the end of today's presentation. Please feel free to ask questions at any time via the questions panel on the right-hand side of your screen. We'll leave time at the end to get to everyone's questions. I'll now go ahead and pass it over to Jesus for a quick introduction.
Hello, thank you, Haley. Thanks everyone for joining. So yes, I would like to introduce you to some of the new use cases that are now possible after we added this new SparkRM component to our Hadoop connection to Hadoop in RapidMiner, and you'll see especially how much new functionality and new uses are now possible. So let me go a little bit to the agenda today. So first I would like to introduce, again, Hadoop. You may know how it works, but I would like to also review how it works and how it has improved during the last releases. And then we will go through a couple of use cases and see how specifically SparkRM and in general Hadoop helps with that. The first use case will be based on risk prediction, but more specifically we'll see how this SparkRM feature will help during the data preparation phases and training and application in different ways with segmented models or with bootstrap models. And then we'll also review a second use case, which is sentiment analysis, or more specifically also text analysis. This one I think it's especially interesting because it's something that is not really easy to do in Hadoop environments. There are libraries for all the types of algorithms, but there is hardly anything in the market for text analytics in Hadoop. So I think this is quite interesting that we have added this new functionality. Going straight into the architecture. So this is in a picture how Hadoop works. So on the left you see a RapidMiner Studio process. It's very similar, not identical to another typical non-Hadoop RapidMiner process, where you see how a workflow is designed, is built using these operators, these boxes, which contain different pieces of functionality, which is related to, let's say, data preparation or machine learning functions. So if you see there are things like read log or select attributes or join or decision tree, and I want to remark that this is exactly the same in Hadoop, and it's not related to the infrastructure. You don't really need to know about I don't know, HiveQL, for example. If you want to do data preparation, you don't need to know any Spark code. It's just about the functionality. So the objective here that we had when we developed Hadoop was to let people focus on the data science side, so on preparing the data, on analyzing the data, on adding new algorithms and so on, while forgetting or being much more transparent on the infrastructure side. So here on the right side I have drawn something like what a Hadoop environment would look like. As you know, Hadoop is not really a single technology, it's a bunch of technologies all working together, doing different things. So we have, for example, on the far right, this HDFS piece which keeps the files, the data themselves, takes care of replications or all that, while more on the left we see other pieces which, for example, Hive is an SQL-like engine that helps in getting or analyzing the data in HDFS. Impala is another option. Then Yarn is the scheduler. Spark contains other functionality, more really the actual functionality of the libraries and the execution framework and so on. And all these pieces we can make use of in using Hadoop. So, for example, most of the data preparation operators, like the ones to generate attributes or select attributes, filtering, and so on, make use of Hive. But again, as I've mentioned at the beginning, you don't need to know anything about HiveQL. You just need to know what you want to do with your data. You want to, as I say, filter or aggregate or do something like that. By the way, you can use HiveQL if you want. We have an operator where you can paste a specific Hive script, but you don't need to. And similarly with Spark. So you can we provide operators for various MLlib algorithms. In this case, I've drawn the decision tree, but also different regressions, logistic regression or linear regression, and others. And we also provide a way to use SparkR and PySpark to, similarly to what I've said with HiveQL, paste your own code and make use of that. Now that's the traditional Hadoop point of view, where you can, as I say, have operators for preparing the data and also for training models, also for validating. We have the split validation, performance calculations, and so on. So basically create a full process end-to-end from reading the data to applying the data and operationalizing all of that. And what we have now new is this SparkRM box, this SparkRM piece, which we use to also send, let's say, RapidMiner scripts, RapidMiner visual processes encapsulated to Spark. So we can run them in a similar way as when one takes an R script and sends them to Spark using SparkR for execution. We can take our RapidMiner processes, sometimes one single operator, sometimes a full subprocesses, I've said, send them to Spark for execution, and also, by the way, in a parallel way, so we can really make use of all the power in the Hadoop environment. We'll see now in the demo how that exactly works, and that's the main change we have added, right? And that I wanted to share with you. That's about the architecture. Let me go to the use cases. So first use case is based, as I said, on a risk use case. We'll play, so to speak, with a table similar to this one, where we have basically a database with information from some bank clients, where we see the name, the job, what they have done before in other credits, if they have previous debts, things like that, and especially things like whether they returned the credit or not, or if they defaulted, right? That's what we have. And then what we want to do is to predict the future behavior. So will not necessarily these clients, but especially other clients, will other clients return their credits? Will they default? That's what the bank wants to know, and that's what we want to see in this case. It's a typical classification problem, so it's just an example. Many other use cases can be used as examples, but that's the one we'll be using by now. We'll be checking by now. I'll introduce the second use case I've briefly mentioned before, the sentiment analysis. But before, let me go to the demo itself, because I think everything will be clear in that. So let me go to the RapidMiner Studio. So some of you may already be familiar with this. This is our canvas where we'll be designing our processes, and what we'll be doing is I'll show how this use case will be solved in different ways using Hadoop and SparkRM. Before, let me check here in Hadoop data. I have a connection to a live Hadoop environment, right? I'll check here, so I can connect here to the environment and then see the, for example, the data that I have. I have different tables here, and let's check this one in particular, which is the one I have shown in the slides, and we'll see a little bit of it. As you can see, whenever I show data here in this Hadoop data view, and this is different from the typical results in Studio in general, this one is always sampled, right? And the reason is, of course, Hadoop data is big data. I don't want to show 5 terabytes of data here, so it's always sampled. You can, there are settings to increase or reduce the sample size, but it's always sampled. This is a table, as I've mentioned, basically lots of information of each client, and then these things that we want to predict, being creditworthy or not. And based on past behavior, again, we'll need to predict the future. As you can see here, we have very similar things to, or similar information, for example, similar statistics and so on, as we would have in proper Studio. Also the charts, all the different types of charts that we have in Studio. Difference is, of course, this is all based on sample data, so we cannot really rely on this data as accurate data. So, for example, in terms of averages, if we actually want to calculate the average, we need to do it using the aggregation operator. This gives us a basic idea to explore the data, and that's also very, very useful, but that's it. We can, by the way, also execute direct Hive queries here. So again, we can also still use Hive directly, even if for most cases we don't actually need to code anything or to use any SQL query. So let me then go directly to the first process. So everything that is related to Hadoop goes inside this kind of nest operator, which basically deals with the connection. I have different connections configured here. I select the one that I need, and everything that happens inside, as you know here, this means this is a sub-process. I can get inside and see my actual process. This looks pretty simple. I'm retrieving this table that I have shown, set the role, and then I have this SparkRM operator, which again will contain a sub-process. So I'll get here inside, and this is what I have. And as you can see, this is these two operators are standard Studio operators. They are not Hadoop, they are not MLlib, Spark MLlib, they are not Hive, they are just standard Studio operators. Why am I doing this? Well, the first thing I want to do, by the way, with this use case is we have seen here in the table that there are quite a few, let me show it here, quite a few attributes, and I want to see which ones are relevant and which ones are not. I mean, I have 21 regular attributes and the label, so I want to see which ones are important. So I want to calculate correlations, right? So what I'm using this specific operator, which I don't have available in Hadoop, so I want to use it here, and then I want to then transform this to this data. Let me just run it, right? And then, by the way, I can take this information outside and store it here in my RapidMiner repository, my local repository. It's obviously in most cases I don't want to get anything out, so everything, the full process will be inside Hadoop. I don't want to move data in and or out, and in this case, for example, this data table is not moving from the Hadoop environment. All the calculations here, even if I'm using RapidMiner standard operators, are happening on some Hadoop node, right? And the result will be just here. In this case, because it's just a weight, and because I want to show it later, I will take it out because this is just a weight, and so it's a small table, and keep it in my repository. I will be doing also that, for example, for models, for performance results, and so on. So even though everything can happen, and most things will happen within the Hadoop environment, moving data in and out of Hadoop is also possible, right? So here we have the results. So I have the attributes, and I can see the weights. So with these, I know that, for example, the most important attributes, the most relevant for my problem, will be probably these 3, 4, right? The most important one, in fact, is the status, right? It's like more than twice as important, right? So here, if you remember, or if you've seen, status is related to how much money I have in my account, right? And it could be that I don't have any account, or is less than 0, so I have a debt, or less than 200, or more than 200, and those are like the most relevant information that I can have in this case, right? I can see it in the results here because I have connected the final connection, the final line here. But I can also go here to my results. This has been just created now, and I can go and directly open it from here, right? See, I can see here, and I can see again this example set, and the statistics. It's just the same as before, right? So this is it. So next thing that I want to do with my data is, once I know what the relevant attribute is I want to use that as a proper segmentation, right? So I want to see if I can create a model to understand the behavior, to predict the behavior of these users, these clients. But because I know that this status is very important, maybe I want to create different models for each of these segments. So as you've seen, I have here, not here, I have these 4 different segments. I want to use those 4 and create specific models for each of those, right? In a different use case, it could be something related to, for example, gender, so specifically, or age. For example, I could have a specific model for people who are older or younger, or people who have different types of jobs. So any segmentation is possible, right? So in this case, again, I have my Hadoop nest, and inside it I have this process which looks similar and pretty easy. And here I have this SparkRM process, and we have not seen before the parameters, the configuration. In that case, by the way, because it was just a calculation of this segments of this correlation, it was calculated in a single node. But I have in the introduction mentioned that SparkRM can also parallelize the processing, right? And the way we parallelize is by parallelizing actually the input. So in this case, I have this this table, and I can, let me go back here, I can split it into different different parts, and I will run the process or the sub-process inside SparkRM, inside this operator, on each of these pieces of data, right? And I can partition the data in different ways, in these different modes actually. So the just to review a little bit, linear mode means just as it is. So as you know, HDFS and Hadoop automatically partitions all the data, so that any data that you save will be in different nodes. So when we check here linear, we will just make use of that partitioning, and that's the fastest way of going. But on the other hand, we don't have any control on how that partition is made. It's just the decision of HDFS. So we can use, for example, random. Random means that I can control the number of partitions. I could have maybe 10 partitions or 5 or as many as I like, or I could have absolute size partitions, like I want to have each partition of 1 gigabyte or 10 or the number that I like, right? So in this case, all the partitions are basically the same because it's distributed by random, but I can control the sizes. And then there is this other option which we'll be using right now, which is more related to the actual meaning of the data. So in this case, we'll use this attribute status as the criterion. So there are 4 possible values of this attribute. So there will be 4 parts in this partition, and so we'll reshuffle the data to make them match these 4 parts, and then this code inside SparkRM, what I see here, I'm sorry, will be this subprocess will be encapsulated and sent to the nodes for the execution. In this case, I'm getting, by the way, a macro, which is like the annotation, just to see. It's here, by the way. I have generated a new attribute which is related to these partitions, and here I'm selecting the subprocess. And by the way, I'm doing something that is one of the options that I have. So I could just send the same algorithm to all these parts, but the good thing here is I can select each one, right? And I can, for example, say, well, in this case, I'm using this minimal gain or this depth, but for selection number 2, or like the second option, this is different. For example, here I'm setting a different minimal gain because I can refine the model of each of these segments in a different way. As I've said, I could just select all of them in the same way and say, well, just train this this model adapted to these 4 segments in a different way. But I can also refine those and reconfigure the models in a custom way. Right? I'm using specifically the decision tree, even though, for example, the decision tree is something that we have in MLlib, because this is easier to show and more understandable. But of course, all the operators that we have here, and that we have like many more than in MLlib, like neural networks, all the types of trees, random forest, shade, Bayesian, support vector machines, all those are available within SparkRM, right? So let me start running it so that we can see the results. So now that I am running it, what's happening is this is being split into 4 different parts. and this process is being encapsulated and added and sorry, sent also to the different Hadoop nodes for execution, right? I can even show, it will take like a minute or so. This is the interface of my environment, of my Hadoop environment. So if I refresh, I will see my processes being sent here and running. So it's here, right? I can see it's running different containers. I can take a look at the application master, for example. This is all Spark. I can see the jobs, the stages, and so on, and I can monitor it in my own Spark environment, right? That's what's happening here, right? Let me go back in here. As you can see here, I have on purpose added this sub-processes because I wanted to show that sometimes I just need to one particular algorithm and just add it here, but sometimes I can get full sub-processes as complex as one likes and send it all together as a single piece to the different Hadoop nodes. Right, that's the way. Once this finishes, we'll get this result. And by the way, as you can see, because we have 4 processes or sub-processes in this case for segments, we get a collection, right, with 4 models in this case, right? So this is the model, and by the way, this has an annotation, so I can know that this is for the partition of less than 200 euros, right? So I can see this is how it would get. So I can analyze what the different branches of them are. This one is for less than 10. It's the most complex. So maybe if this is the most complex, or for example, this is very, very simple. So I could go back and try to change the configuration of this particular tree without changing this one, right? This is because I can have these customization options, right? This is also something interesting. As before, I have taken out and stored just the models because the models are pretty small, so they are here in the results subfolder. Right? So I have now a collection of models. So what should I do? Well, I can now apply these models, right, using again Hadoop. In this case, I retrieve the models from my repository, and what I get inside is again SparkRM, where I am here getting the data. So as you can see, I get the models from outside Hadoop, but the data is still from inside Hadoop. And here again, I'm doing exactly the same thing, but in this case, I'm applying the model. I can apply the model also within Hadoop, but in this case, I've done it to make it consistent with the previous process, and also to show some of things here. Like in this case, I have a collection of models, so I'm selecting exactly the right model for my data. So again, in SparkRM, I have selected this attribute and status as the partitioning criterion. So here, when I'm getting inside, I also need to take this collection and select exactly the one that I need, which I can just select because all of them are annotated, so I can know which one corresponds to which data. I have also added a new column, which is like the model for us also to, let me also run it because it takes a couple of minutes. So I've added this new column for us to make sure that, or to show rather, that exactly that that model, the right model, is being used for the right data. Right, that's the thing, right? That's the idea. That will be part of the process, and then what we'll be doing is check performance, right? This is very important whenever we apply data, and especially in this case we have trained and then apply the data. We want to calculate the performance, the accuracy in this case, and we'll be storing the scored data. As you see here, I'm storing the table within Hadoop, so everything here will be happening in Hadoop, but also the performance table, the confusion matrix and so on, will be going out and stored in my repository. So I could also do some model management and store different results, for example, from different models in my repository, then check which one is best and so on, right? Also, one thing that I want to remark here is that I can very easily mix operators from both sides. So in this case, for example, this is all using, behind the scenes, this is using Hive and HiveQL. Here I'm using a Spark, but inside it's a RapidMiner subprocess. This is using, again, Hive, and also the storing is using Hive. We could combine with some of the Mahout operators that we have, with the SparkRM lib. Anything can be mixed, and just communication from one to the other is as easy as connecting these dots, these ports. Right? It's that easy, and that's basically how this would work. Right? It's already storing it. Once it's stored, we'll actually see the table in here. Right? So here, if I refresh the object, there will be here the score data. Right? We from here, and there's the file. So again, it's scored, and I can see the data. And here in the data, as usual, when I score, I can see my old, this is the label that I had. This is the prediction of the model, and this, like that. And then I also have the confidences for saying yes or no. I can review different things, even sometimes it has not been fully accurate. So I can again go back here, and I have my performance table stored there, so I can see accuracy 98%, this class recall, class precision, and so on. So I can review what has happened, how good this model has been, right? Next thing would be, well, yes, another thing that I wanted to show is, well, this time we have used this kind of segmentation, but there is also something, some other ways. I have said, for example, at the beginning, another of the options was using this random thing. Another functionality is using this bootstrap mode, right? So if I don't use bootstrap, it's when I can select all these things. We have also added this bootstrapping mode where the data, the input data is split in a way that just a subset is selected, adding all the rest of the data. So it could be with repetition, so repeating, and then this goes inside. So it's pretty much like the bootstrapping that one uses in a decision tree to make it into a random forest, right? So if I go here and I'm using a decision tree, I can, by the way, use this operator called combine models. Let me, by the way, run it. So it's already starts. We can combine these models to create a single back-in voting model. So the end result of all this is basically to make, in this case, from a decision tree, a random forest. In this case, it's something we also have in MLlib, but of course we can repeat this with logistic regression, support vector machines, and just any other model where we can get basically a back-in model out of a multiple model result, like in here. The output of the SparkRM is basically a collection of models, and then here we have just the combination, the final model. One thing that I also want to talk about here is, well, here is the model themselves, so I can see each of the models in the each of the trees, and this is, as you can see, just a single model, but it's collected into a backend model. I can see it here again. Here's the model that I can use. It was not a collection, but a single one. Another thing that I wanted to remark also here is that even though I have said at the beginning, we make, and you have seen, we make the resources and the infrastructure transparent. So I have worked with this, and I have mentioned it's Spark and it's Hive and so on. We don't really need to know about it. We do have some control on the resources, right? So the sizing of the cluster is sometimes important, so we can do things like limit the cluster resources that can be used and taken up by this process. We can, for example, select the memory of the driver, of the Spark driver. So this is basically what's used by the application master. And also in terms of the executors, we can decide like the amount of memory of the that it will be used in each node. So I can, if I select less than that, it will probably use more nodes with smaller jobs or larger nodes and so on. So you can have some control, even though these default parameters have been quite carefully selected to work in most environments. You have some control depending on whether you have large needs for large memory or not. That's what we would do. Just to finish with this, use case, just let me now apply this model. So similarly to what we've done before, we do the same, but in this case, because it's just a single model, I have used the standard Hadoop apply model. So in this case, everything, as you can see, is based on the standard Hadoop, and also everything is Hive in this case. This also gives me the opportunity to talk about something we also have added, which is we already had supported the configuration with Hive on Spark. So Hive was traditionally run on MapReduce, but now it's also possible to select Spark or also Tez as execution engines for Hive. Usually Spark and also Tez are faster than MapReduce, so it's something that we recommend. And also we have added further optimization on that, because as in this case, for example, there are different HiveQL tasks, and if we go here to this one, we'll be reusing the Spark containers in this case. So I think we finished, so it's probably there. So, but we have used just a single here application master for all of them, and the containers will be there. So it's much faster because we don't need to restart a Spark container every time we have a task for Hive. So it's optimized that way. So that's basically on this use case. So SparkRM has helped us first for the segmentation, because we wanted to use some very specific operator, even if it was run on one node. It allowed us to use this segment-based modeling when we have different models for different segments and run them in parallel. Also for this, in case of a single model, we also used this parallelization from SparkRM to create this bootstrapping and making the use of this also parallelization. We also have this performance. So in this case also we can compare. I mean, we use both for the same use case, so we can check. And in this case, the first option was clearly better than the second one. So by using this first segmentation, we added some points in accuracy. So this is also allowing us to have better possibilities. So even if we could, for example, try SparkMLlib libraries and so on, this is giving us more options to get better data science, better performance for our process. That was on that use case. Let me go back for a minute to the slides again, because then there is this second use case, which is sentiment analysis. In this case, what we have is a database with movie critics, so basically people saying things about different movies, and then someone has made an assessment saying, well, this was a positive comment, negative comments, and so on. And what we want to do is be able to use this existing knowledge to assess the sentiment on other text, similarly also related to, in this case, movies and comments on movies. That's the basic thing, right? This is the example. Let me go through the model again using the Hadoop nest, and again using SparkRM. Let me start running it because in this case it takes like 3 minutes or so. So this goes in three steps. First, what I'm getting is, as you can see, I'm using the text processing extension. You may know we have this text processing extension where we can process documents, do things like tokenizing, transforming the words, filtering, and so on. So it's basically for processing the text. It's not something specialized on sentiment analytics. There are some extensions for that, but this is for the processing. But we are also using some, in this case, pre-processing. Like in this case, we are also extracting the word list of a series of documents, and then I'm using SparkRM here to again process the documents and use a vector machine, a support vector machine, to be able to predict that kind of sentiment. So I'm getting a model right from there. So the whole output of this process will be first here a word list, and then in the second place a model. In this case again it's a collection that will be backed into a single model here that will be used with different texts to get that sentiment prediction, right? In this case it's a sentiment analysis, but it's just an example. We see there are other cases in our some of our uses who uses, for example, do things like log analytics, which is probably more typical in a Hadoop environment. Logs is something that most people save and keep there in the Hadoop environment, in the HDFS. We could, for example, read those logs, transform them or process them using our text processing extension within SparkRM, and then either in this case use models for prediction or just use this kind of text analysis and processing. I'm using, by the way, again, this text processing because it's probably one of the most popular extensions that we have, but we have several others, and all of them can be used within SparkRM. Typically, for example, a value series extension is one of them that could be used. The Weka library, for example. Also, for example, we have a process mining extension that could be used for that. So, as I say, any of them could be could benefit from SparkRM. This has finished again. The output, as I've mentioned, this word list that we have here, the ones used there, and also here I get the model, right? This is the sentiment model. In this case, it's a support vector machine. So what we have here is just this kind of description with everything the model has, right? And then just to finish, again, I want to apply this model I have just created. I get from outside, again, the model and the word list in this case, and then I get inside and run this this process again, right? This, by the way, the single process pushdown operator is the single node version of SparkRM. In this case, I'm using one node because what I want to analyze is that this single text, as I was mentioning, I was trying to predict if this is a positive or a negative comment. So here, for example, I can't in good conscience recommend it. Maybe the model has an issue because it has the word recommend or best or things like that. So it could be positive, but let's see what the outcome is. It gets to the process and then it gets processed just to get rid of filter some stop words and so on, and then it will be the model will be applied, right? So again, this will take like a couple of minutes, but this is the way it basically works, as I've said, and these are all the options. So going back to what I mentioned at the beginning, because we now have this SparkRM process added to the existing Hadoop operators, and I want to remind all these operators that we have for data access, data blending, modifying attributes, and so on, the tables, cleansing, normalization, missing attributes, lots of different models and segmentation and so on. Also validation, by the way, I have not mentioned, and some others. We also add, in this case, is also finishing. This is also adding a whole new set of use cases related to, for example, all the extensions, but also things like this bootstrapping, parallelization of all the operators that we have in here, which are some of them not available. I mean, comparing putting modeling with more than 100 here. There are a lot of new things that that are available, and I have. We go back to the results. By the way, the model was successful, even if the text had things like best and recommend and so on. It knew it was negative, so it was successful in that. And again, all these use cases, I think, open a new window of opportunity of things that can be done with Hadoop and also with Hadoop in general. And so we're getting to the end of it. That's more or less what I wanted to say. So yeah, let's maybe spend some time with questions that you may have.
Great. Thanks, Jesus, for the presentation. And as a reminder to those on the line, I'm getting a couple questions, but we will be sending a recording of the presentation within the next few business days via email. So look for that email with the email that you registered with. I do see that we have a couple questions that came in, so if you guys have any questions for those on the line, feel free to input your questions into the questions panel. That's on the right-hand side of your screen. I'll go ahead and ask some of those questions now. So the first question here is, can you provide an insight on the Hadoop integration with AWS, specifically EMR?
Yes, so we actually have an integration with EMR. For example, in this, I mentioned the Hadoop Nest contains all the connections that one can choose from, and we support different Hadoop distributions. So it's configured here. So we can, for example, this one in particular was a Cloudera, but we support Amazon EMR, sorry. We support Hortonworks, Open Data Platform, and some others. And we are, by the way, also working on adding some others like Azure's HD Insight and some others. So we support different distributions, also the standard Hadoop from Apache, and EMR is one of them.
Great, thanks. Another question here, how is SparkRM different from running an mlib-based operator?
So it's the difference. So for example, you can see that we have some, not here, but here, some operators which are for modern algorithms in the standard Hadoop, sorry. So logistic regression, linear, some decision trees, and so on. All these are based on, as you can see here, SparkML and we are just calling them through Yarn. So the advantage here in using Hadoop is this is just the box and you are configuring it, so it's much faster and easier to develop and design the processes. In the case of SparkRM, what we're doing is we're using our own algorithms. So you have, if you want to use a different decision tree algorithm or support vector machine that we have, for example, here I can show very different decision tree algorithms, different support vector machine, and so on. So you have all these new options. And the other difference is that in SparkML Lib, the algorithms are parallelized by themselves, so it's a parallel algorithm. Not all algorithms are parallelizable in their own nature. What we are doing with SparkRM is we split the data and make it parallel that way. So that's why we end up with a collection of models, and then you can combine if you want. So if you use a SparkML Lib decision tree, for example, you end up with a single decision tree trained on all the data. If you use SparkRM, you get a collection of decision trees. Right? That's the difference.
Thanks, Jesus. Another question here, SparkRM, can it be useful for data prep?
Yes, actually it can. I showed a little bit with this segmentation, but in that sense, for example, and one of the things is using this attribute-based partitioning. You can use it as a kind of loop value. So we have in the standard Studio one loop called loop values, where you can select all the values for a single attribute, and then you repeat the same task for each of them. SparkRM can work a bit like that. So if you can have the same or different data preparation tasks depending on a segment, for example, you can use it for that, and that would be quite useful. I have seen a couple of examples in real use cases for that.
Thanks, Jesus. This next question, I believe you covered it, but I'll go ahead and ask it again. Can I control the resources requested by SparkRM?
Yes, actually, it's something. Sorry, this one doesn't have it. Let me go back here. So you can. We have developed it in a way that it's very transparent. So these parameters are selected so that it would work in most environments, and there are some heuristics algorithms within both Hadoop in general, also with Hive, and in particular with SparkRM, to select the right or request the right resources from the Spark scheduling system and from Yarn. But you have some control in changing, for example, the driver memory, the cluster, the amount of cluster resources, and so on. So yes, you can control to some extent the resources used by these processes.
Great, thanks. So it looks like we're about time here. We got some comments. Thank you for the presentation. So thanks again to Jesus. If we weren't able to address your question here on the line, we will make sure to follow up with you via email within the next few business days. So for that, thanks again, everyone, for joining us for today's presentation. Thanks again to Jesus, and I hope everyone has a great day.
Okay, thanks, everyone.